Okay, in this presentation we are going to look at a continuous random variable. Suppose the random variable x has the following probability distribution. So here we have the notation for the probability distribution, small f with a subscript of capital X to denote that that is connected to the random variable x. So f of x equals 3 over 2 times 1 minus x squared, where x is between 0 and 1 and 0 otherwise. Okay, so this is the key interval of values for x that we're interested in. Anything outside it we can sort of disregard, because anything that we integrate will evaluate to 0. So the integral of 0 is 0. Okay, so anything outside that interval we can just disregard. Okay, so complete the following exercises. Confirm that the f of x is a valid probability distribution as defined above. Calculate the expected value of x. Calculate the probability of x being between 0.3 and 0.6, and then calculate the probability of x being greater than 0.7. Okay, so first off, part A. Well, before we get to part A, what we'll do is just remark that this is an indefinite integral here. The integral of 3 over 2 times 1 minus x squared dx equals 3 over 2 times x plus x cubed over 2 plus c, where that is the constant of integration, essentially. It'll sort of not really feature anymore when we get into definite integrals. Okay. Now, by the definition of the probability density function, the PDF, that should evaluate to 1 for this definite integral here. So minus infinity to infinity of the integral from minus infinity to infinity, I should say, of the probability density function dx equals to 1. Okay. Now, as I sort of said, we can compute the integral for the range of values from 0 to 1, because everything outside that range will evaluate to 0. So essentially what we can do is just replace this expression here with this. Okay. And basically all we have to do is just confirm that. Okay. So previously we just actually worked out that indefinite integral. So what we have to do is evaluate it from 0 to 1 as a definite integral. Okay. So 3 over 2 times x minus x cubed divided by 2. Evaluated at 1, we have 3 over 2 minus a half. When we evaluate it at 0, we have 0 minus 0. 3 over 2 times 0 minus 0 cubed over 2. That's 0 minus 0. So essentially, this whole thing goes to 0. 3 over 2 minus 1 half, that is equal to 1. Okay, so it does work out as a valid probability density function. So moving on, what we have to do now is calculate the expected value of x squared. A very similar sort of approach here, but rather than integrating the probability density function, what we will do is integrate x times the probability density function there. Okay, so we have x times our probability density function as defined previously. What I could do is take out 3 over 2 out of the integral, just keep it as a constant up the front. Okay, so what we have there is an integral from 0 to 1 of x minus x cubed. Okay, and we could just break that up into two parts there. What I'm going to do is integrate both of these and evaluate them at x equal to 1. We sort of can disregard x equals 0 because we know they're going to work out to be 0. So 3 over 2 times the integral of x dx, that is x squared over 2, and x cubed, that is, when we integrate that we get x to the power 4 over 4. So essentially we have this expression here. So that is 1 squared divided by 2 minus 1 to the power 4 divided by 4. That works out to be 1 half. And again, when we integrate that, when we evaluate that at 0, this works out to be 0. So we could just disregard that. So that's our constant that precedes the integral. Okay. So 3 over 2 times 1 half minus 1 quarter. That is 3 over 2 times 1 quarter. And that means our expected value is 3 over 8. So that's part B. Now, this range of values here, calculate the probability of x being within that range of values. So that, what we're going to do there is evaluate the integral of our probability density function using the upper and lower bound as the limits of integration. Okay, the bounds of the integral. The integral, if we recall, is 3x over 2 minus x cubed also over 2. So we have x squared here, and when we integrate that, that is x cubed over 3. But when we multiply that integral out by 3 over 2, then we end up with x cubed over 2. Okay, so our interval here is 0.3 to 0.6. So what we're going to do is evaluate it for x equals 0.6 and then x equals 0.3 and get the difference. So x equals 0.6, what we have there is 3 times 0.6 over 2 minus 0.6 cubed over 2. That works out to be 0.792. And when x is equal to 3, we have 3 times 0.3 divided by 2 minus 0.3 cubed divided by 2. That works out to be 0.4365. So when we get the difference between the two, we get 0.3555. Okay, so that is the probability that we are looking for here. Okay, 0.3555. So the last part is calculate the probability of x being greater than 0.7. And essentially the trick here is just to re-express that as the probability of x being between 0.7 and 1. So we're more or less using the same approach as we have done previously. Here the definite integral is a definite integral from 0.7 to 1 of 3 over 2 times 1 minus x squared dx. So it's essentially the same approach. What we do there is get the interval and evaluate it for 1. We have 3 over 2 minus 1/2, which is 1, and work for 0.7 we have 3 times 0.7 over 2 minus 0.7 cubed. That should be, actually, apologies, that's 0.7 cubed divided by 2. Working that out, that should give us an answer of 0.1215. Okay, so that is part D. Okay, we'll leave it there.